Maybe time is really running out. Maybe it's our colonial history and spirit for exploration. Maybe this will never happen and we will always be Earthlings. But we still have to talk about it. Colonizing space. Space as in the void, or space as in other terrestrial destinations. What will it take to make it out there? What will we have to change? Give up? What will we have to do? This is Fact and Science Fiction. I'm your host, Carly, and this is Part 1, Colonizing Space. The reason I'm doing a two-parter for Leaving Earth is because a lot of attention is paid to colonizing Mars or some other planet or moon. When we think of colonizing space, we think of terrestrial environments, but not a lot about a space station like the ISS or another base that would be revolving in orbit or somewhere out there that would house people. Even though a lot of science fiction depicts stories like that, like Interstellar and The 100 for example, I think it's because we would definitely prefer where we could go outside and explore. But I did a Twitter and Facebook poll, very scientific, and most people voted that we'd live in some sort of habitat or domes, rather than live in a giant space station or successfully terraform a planet. In their book Science of Star Wars, Mark Brake and John Chase discuss colonizing the moon first. It would definitely have its challenges. There are huge temperature swings from 270 degrees Fahrenheit to negative 270 degrees. It's constantly hit with micrometeorites and cosmic rays. Brake and Chase definitely lean toward terraforming our new home rather than building habitats or domes, writing that subterranean tunnels would be a good home for settlers. In the moon's ancient past, hot magma flowed underground, and as the lava reached the surface, it cooled and formed a hardened lid that contained the flowing lava. When the lava stopped flowing eventually, the underground became hollow catacombs. The underground catacombs would be a valuable living space, as long as we could figure out all the resources we would need. Food would need to be brought up with us initially, and then be resupplied with supply ships. However, there is evidence of water on the moon in the soil. We'd have to completely revolutionize how we grow plants in order to become agricultural again. The sun's rays are not dispersed in the thin lunar atmosphere like they are on Earth. There are no insects to pollinate plants, and nights are incredibly cold. Perhaps we could create a greenhouse dome on the surface for agriculture while we live in the lava tubes, but it would be really difficult to make enough food for a large group of people. In Artemis by Andy Weir, lunar settlers subsisted on nutritious algae and reconstituted pastes. In Becky Chambers' books, it was easy to cultivate insects to eat, which is what some companies are working on now. Some insects like crickets have a lot of protein, and they're much easier to grow. Mars is another widely discussed possibility. Mars has 24-hour-long days, has seasons, and polar caps, all like Earth does. Mars, however, doesn't have liquid water, and it's also plagued by dust storms and solar radiation that's worse than what we have on Earth. If we wanted to make Mars more habitable, we would have to warm the planet. Humans have been doing that to Earth in record time, but it's still taken several generations. And if we melt the polar ice on Mars, the water would cover a lot of the planet. We'd also have to figure out how to grow our own food on Mars. How does bacteria work up there to biodegrade waste and create rich soil? Scientists are studying how those processes occur and how we'd control those processes on Mars' atmosphere. This was a big part of the film The Martian.
Right. Let's do the math. Our service mission here was supposed to last 31 souls. For redundancy, they sent 68 souls worth of food. That's for 6 people. So for just me, that's going to last 300 souls, which I figure I can stretch to 400 if I ration. So I got to figure out a way to grow 3 years worth of food here on a planet where nothing grows. Luckily, I'm a botanist.
Mars also has huge volcanoes, leading to lava tubes just like we talked about on our moon. So we could have underground bases in these catacombs at first as we develop agriculture and resources for long-term settlement. One of my favorite science books is Packing for Mars by Mary Roach. It's evident that she and NASA think of everything when it comes to astronauts traveling to Mars. What they breathe, what they eat, what they use as toilets. NASA is studying this in their experiment High Seas. If you listen to Gimmelt's podcast The Habitat, you're already familiar with this experiment. But in case you aren't, High Seas, HISEAS, is a small dome about the size of a tennis court in a remote part of Hawaii. It's the closest environment on Earth to what we would experience on Mars. It's built on volcanic rock, and the volunteer astronauts in High Seas explore and take samples of lava tubes there. It's mostly an exercise to see how living in a dome similar to a Mars habitat would affect humans. They have to wear spacesuits when they go outside, and they share this small dome space for a year, with different crews each time. They've learned a lot about psychology during these missions, I'm sure. But that's not enough for some people. A small Dutch organization called Mars One is determined to land the first team of astronauts on Mars to settle the planet. Or at least it's determined to manage and coordinate the first Mars settlement mission. They are planning a one-way mission, and they aim for 2030s for their first manned launch. Mars One doesn't build space shuttles, but wants to coordinate with space agencies to do so. The organization says on their website that Mars One mission design is currently in the early mission concept phase, or as called Phase A. The top-level requirements for the mission have been identified and discussed with established aerospace companies. The team of Mars One's astronauts is still being decided, from their website. Research I've discussed in the last few episodes involves finding exoplanets. Planets that are like Earth, in this Goldilocks zone that could support life. Researchers use all kinds of interesting methods to find exoplanets. I've discussed using prisms and spectroscopy. One of the problems with finding exoplanets with our current technology is that the images we see with our telescopes are just a few pixels of data. You may have seen early pictures of Pluto or Jupiter, just colored dots. What can we learn about planetary life from a single dot? Stephen Kane of the University of California, Riverside has come up with a way to answer that question using NASA's Earth Polychromatic Imaging Camera on the National Oceanic and Atmospheric Administration's Deep Space Climate Observatory. Wow, say that 5 times fast. These high-resolution images document Earth's global weather patterns and other climate-related phenomena. Kane takes these high-resolution images and collapses them down to those few pixels that attempts to simulate the interference expected from an exoplanet mission. The camera Discover takes a picture every half hour, and it's been in orbit around 2 years. Its more than 30,000 images are by far the longest continuous record of Earth from space in existence. By observing how the brightness of Earth changes when mostly land is in view, compared with mostly water, Kane has been able to reverse engineer Earth's rotation rate, something that has yet to be measured directly for exoplanets. So he's basically comparing these images of Earth to what the kind of images we have of exoplanets, with the idea that, hey, I know that the image of Earth is like this because of this climate or because of this atmosphere, and then applying those assumptions to exoplanets. Last year, researchers discovered 7 Earth-sized planets orbiting a star 40 light-years away. Now remember from the last episode just exactly how far 40 light-years is. These planets are called TRAPPIST-1 planets, specifically TRAPPIST-1a, TRAPPIST-1b, TRAPPIST-1c, and so on until TRAPPIST-1h. Their star is TRAPPIST-1, which is named after the Trappist monastery's beer, because astronomers love beer. That's just a fact. The planets are so close to each other that there are 7 of them within a space 5 times smaller than the distance of Mercury to our Sun. The Sun is smaller and cooler than ours, but it's very active. Scientists say these planets may be very dark, but still warm, because of its rays. If you stood on one of these planets, you could see the nearby planets in the sky just as big or bigger than the moon is to us, which would be wild, looking up into the sky and seeing 6 planets. These planets could have a similar atmosphere to Venus or Earth, but more research is needed. But planets B, C, and E seem to be the best candidates for potential habitability. In Netflix's reboot of Lost in Space, Earth has become inhospitable to humans, so the chosen few hundred get to move to a new world, Alpha Centauri. It took months to travel there, and unfortunately the Generation ship falls into a wormhole, and they're spat out on another planet entirely. This planet at first looks habitable. There's oxygen, water, forests, deserts. It looks like Vancouver in most of it. But in the first few episodes, the Robinsons realize that the planet's orbit is a little bit off axis. A nearby black hole is kind of pulling it closer to its sun, meaning that it will be destroyed in a matter of months. I'm only on episode 4 or 5, so I'm not really sure how that's resolved. But in reality, these kinds of scenarios could have happened millions of times. The exoplanets that we're capturing now are the ones that survived. Northrop Grumman and Ball Aerospace and Technologies are building the James Webb Space Telescope right now, and it'll be ready around 2020. It'll be able to get a better look at the TRAPPIST-1 planets and pretty much every other thing that we've wanted to see. The telescope will be positioned 1 million miles from Earth, with an unprecedented view of the universe. It can observe large exoplanets and detect starlight filtered through their atmosphere. It's supposedly a follow-up to the Hubble. Just this last May, scientists reported that they have detected an exoplanet atmosphere that is free of clouds, marking a pivotal breakthrough in the quest for greater understanding of the planets beyond our solar system. An international team of astronomers have found that the atmosphere of the hot Saturn, WASP 96b, is cloud-free. Using Europe's very large telescope in Chile, the team studied the atmosphere of WASP 96b when the planet passed in front of its host star. This enabled the team to measure the decrease of starlight caused by the planet and its atmosphere, and thereby determine the planet's atmospheric composition. Using the method of spectroscopy that we discussed a couple episodes ago, researchers have determined its atmosphere is full of sodium, which would only be possible if there were no clouds. You've heard of Audible.com before. It's the best place for audiobooks, and podcasters and podcast fans are audio people. Right now I'm listening to Medusa Uploaded by Emily Davenport, and I'm enjoying it so much I want to write about it on the blog. It's a science fiction action thriller taking place in the far future where humans now live on Generation ships, which I will talk about more next episode. You can get this book or another of your choosing by going to audibletrial.com/factandsci-fi. That's audibletrial.com/factandsci-fi. Or you can swipe to the show notes and click the link to download your audiobook with a free trial subscription. Whether we live on Mars, the Moon, or some other planet, a big obstacle would be oxygen. With the exception of Star Wars, I kind of cringe every time a team of astronauts or settlers land on a planet and immediately take their masks off. Like, whew, so glad we randomly landed on this planet that had the perfect amount of air to breathe. The only time Star Wars acknowledged oxygen supply was even a thing was when they accidentally flew in that throat of the giant space worm.
Feel like rock.
There's an awful lot of moisture in here.
I don't know. I have a bad feeling about this.
But of course, science fiction creators make an assumption of oxygen because they don't want to spend half or all of their book telling a story about humans finding oxygen. These kinds of dilemmas are good for brief, thrilling scenes, not an entire story. Except for the classic 80s film, Total Recall, in which the entire third act is about wresting control of the air supply from a corporation. Similarly, in Artemis, the moon habitats are supplied oxygen from the process of mining aluminum on the moon. The process of mining it makes oxygen as a byproduct, and they just push that oxygen into the domes. The aluminum mining is under the control of one company, just like in Total Recall. May I suggest to Mars colonizers that we do not let the air supply go to a private monopoly? Anyway, finding an oxygen supply will be our primary concern when living on another planet or moon full-time. Even if another destination has oxygen in its atmosphere, it may not have enough. For example, Jupiter's moon Europa has a thin oxygen atmosphere, but is far too tenuous for humans to breathe. A MIT researcher, Michael Hecht, has developed a device dubbed MOXIE, short for Mars Oxygen In Situ Resource Utilization Experiment, that's designed to take carbon dioxide from the Martian atmosphere and use it to produce oxygen. MIT describes it as a specialized reverse fuel cell that will consume electricity so it can produce oxygen on Mars, where the atmosphere is 96% carbon dioxide. MOXIE is a prototype for what we'd need to have a colony on Mars, but if it works, then it could be scaled up to support humans' needs. MOXIE is aimed to be on the 2020 Mars rover mission. Colonizing another planet or moon will take the collaboration and hard work of several countries and billions of people. Everyone will need to be on board with creating and supporting an extraterrestrial human colony. When the US had landed a man on the moon in 1969, there was a gigantic backlash. And NASA's funding was cut. A large portion of the public was infuriated that so much money went to one mission while conflicts like Vietnam and social upheaval weren't given enough attention. Maybe that's why so many private companies are getting into the colonization business. Alls I can say is do not give control of necessary resources like oxygen to one company. We've seen too much damage be done because of that already. Don't be like Total Recall. Stay tuned for the next episode about living in space. No terraforming, no habitats. We'd live on spaceships. Subscribe, rate, and review the podcast on Apple Podcasts and Stitcher if that's your poison. Follow the podcast on Twitter, Instagram, and Facebook at Fact and Sci-Fi. Read the script for this episode and other content like the 4 cool science concepts in the new show Reverie at factandsciencefiction.com. And lastly, thanks for listening.